Hi everyone, welcome to your greatest YouTube channel. Good morning, good evening, good night in the places where there is night at the moment. Everyone from the world, hello, hi there. Right, so let's carry on with our IPv4 subnetting. So I've given you enough time so that you can practice, hopefully practice. Right, so IPv4 subnetting. So today the scenario that's been given to us, the scenario we are working on is we have to find valid subnets. If anyone hasn't seen my videos, they can actually go to my playlist and there is networking fundamentals folder, and that particular folder and playlist has got all the videos that I have done. So initially it's just for students who want to learn IPv4 subnetting, or obviously there are trainee field engineers who are working in networking, who use routing and switching, mostly routers, and where these addresses are particularly used. Yes, I think that's perfect. Right, that's what I wanted to say. Right, so now we are looking for valid subnets and host per subnet. Do excuse my writing, it hasn't been the best because we do all the things on laptop, computer, notebooks, etc. etc. Right, host per subnet. Now the solution we have to find has obviously got a question. So we have to enter the maximum number of valid subnets and usable hosts per subnet that we can get. So maximum number of valid hosts, Hello you there, don't worry, it's not boring, hold on, it's all right. Right, maximum number of valid maximum number of valid hosts, and the other thing was usable hosts per subnet. I'm gonna create my own nice bracket. Yeah, usable host per subnet. This sort of question you have to work it out inside your brain, but be very, very careful because these can be very tricky, especially when you're doing IPv4 subnetting or you're giving exam for N+, CompTIA or CCNA, and obviously other versions which are not related to Cisco's where IP addresses are used, like Juniper and stuff. So you got to be very careful with what troubleshooting we are doing, what we need to find out, and relatable things. Right, so obviously with all of this we need a lovely IP address. So in this scenario it's a class B one. So 170, what is 170? Class B, yes. Hopefully everyone has remembered their classes. If they haven't, that's naughty. They should go back and remember them again. Right, so that's our IP address, but in this scenario, to make it easier, it's the network as well. So which means it's our subnet as well. So is it subnet network? Yeah, I think subnet, yes. And now subnet mask is given here on this side. Remember, /26 is your subnet mask, so you can simplify it, and it's called prefix notation. It's called dotted decimal notation. There's so many statements involved with that one, so obviously we can do them, but just to be on the other other sides, what we will do is I'm gonna try to sort of simplify it. So let's have a look. So we have 172 here. We'll break it into octets and bits. So always remember an octet is 8 bits. So this is the first octet. Here, that's first octet. Second octet is 21. So we are just simplifying this one. Now, whenever we are finding valid subnets or usable hosts per subnet, always remember that if you are in class B, then you have to do this. You will be working in the third and the fourth octet always. Now, if you see up here, we got 0 here and 0 here. So for the time being, so obviously everyone knows usually the bits are classified here. 8 bits, 8 bits. So that's all a 32-bit address. 8 plus 8 plus 8, add 8. This one say 8, add 8, add 8. So if you add 8 4 times, so bits are usually displayed here. So what we will assume is, in order to find out our answer, there is a 0 here. So we will assume that we will shift this 0 to 1. So if all the values are 0, we will make them 1. So supposedly, now I'm going to amend this. 1, 2, 3, 4, 5, 6, 7, 8. Right, so we got 8 values here. So that's our 8 bits, remember. So that's our 8 bits here. So that's the first thing you need to do. So if I say, just to make it more prominent and you be sure on this one, 8 plus 8 plus 8 is equal to 8 add 8 add 8 is equal to 24. Right, so now 24 is here, but there is a climax, and the climax is we have got /26 here. So we have only gone till 24 here. So yes, right. Anyone knows? Anyone knows? No one? Okay, it's fine. Don't worry. Next time we'll do that. Right, so what will happen is, now as we know that there's a 0 down there as well, so the same plan will happen, though this time we will only do 1 and 1. That's the 2 bits will go 1. Why? So I'll give you an example. So that's 24 till here. So if we add 2 bits here on 1, obviously 1, so 24 plus 2 bits is going to be 26. Right, hold on. So that's 26 here. So now we got 6 bits left down there. 1, 2, 3, 4, 5, 6. Hold on. I'll tell you what to do with them. It's fine. Don't worry. Don't panic. It's alright. So now we will add all the ones. So when I say add all the ones, what do I mean? So remember, if there was /27 here, I would have shifted one more bit to 1. Remember, so this is very important, that don't just leave it on /24. In order to find our answer, we need to do this. Right, so we have 26 bits here, as explained. Now, I just want you to remember the values of powers of 2. 2 power 7. So powers of 2 are very important. Why I am doing this? I'll let you know why. Right, in a little while. Right. 2 power 8 is 2, 5, 6. 2 power 9 is equal to 5, 12. So there is a sequence going on. So if we add 128, add 128, 256. Or 256, add 256, 512. Now let's add 512 and 512. What is it going to be? 1024. Thank you so much. Right. Now this is where our climax comes in. Now if you see, we will work these powers. So that's 2 power 8. First bit, second bit, third, 4, 5, 6, 7, 8 bits here. And 2 bits here, 10. Yeah? Correct? Alright. So add all ones. So there is 10 ones. There is 10 ones. Remember, so there is 10 ones. So we'll do 2 to the power 10. So these are all your ones is equal to 1024. Guess what? What is it? So anything, we have added all the ones. So anything to the power 2 to the power 10 that comes up as an answer is going to be our valid subnet. So we should write this value here, 1024. Now, first part of our solution is here. But remember, always remember, you got to add all the ones, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 ones. And we'll use the powers of 2. So 2 to the power 10 is equal to 1024. Anyone who's not very good in maths or hasn't done maths before, nothing to worry about. This is just binary maths and it's not really hard. It's nothing like integration, differentiation. I mean, if you want to learn them, that's really good as well. But if you're not into maths a lot, you can still do numerical maths somewhere, somehow. Da-da! Enough of my lectures now, right? Let's go back to the next part. So in the next part, very easy. Remember the formula. Oh my god, I hate formulas. Doesn't matter. We got to do them still. Right. So in order to find host per subnet, always remember 2 to the power y minus 2 or subtract 2. So if you see here, we got to add all the zeros. Or here, add all zeros. So if we do add all zeros, what do I mean? So if we add all the zeros, 1, 2, 3, 4, 5, 6. So we have 6 zeros. So that's going to be our power for 6. 2 to the power 6 minus 2. So as everyone knows, that 2 to the power 6, I think I did 2 to the power 6 is not done a lot, so I haven't mentioned it here. I will mention it, I think, because it's useful here. 2 to the power 6 is always 64. Right, so 64 subtract 2. Guess what? Anyone? What will be the answer? So we have 62. So we have 1024 there. And these are the 62 usable hosts per subnet. Sorry, my video has gone a bit longer, but if you carry on revising these ones, you can actually do this maths inside your head as well, but you need a lot of practice. And where can this be used? It can be done for fun as well, or if someone is a configuration engineer or trainee network engineer, or someone is in uni, they're doing binary mathematics and they need to do IPv4. Though in uni, just remember, I think IPv4 subnetting is always or probably used as a part of advanced networks course. I had advanced networks, but some people might not have advanced networks. So for them, this might not be very useful. But you never know, after your graduation, when you go as a trainee network engineer, or you are doing networking off your home and you want to learn IPv4, IPv6, MAC addresses, so this might be useful to you. For anyone, these videos are not very useful. I would say share them. Maybe someone else might relate to them. And thank you so much. And I'll see you next time. But remember, keep on practicing. And I do say this all the time. When I get time, then I'll do videos on IPv6. I've done some videos on IPv6 and networking fundamentals in my playlist. I'll add this one to the playlist as well. But somewhere, somehow, we might go to the real deal as well, like learning about NAT and just basic stuff. So it gives you an idea, or it gives you the inspiration to move out a little bit of configuration as well, and do a bit of academia as well, like regarding NAT, network address translation, path, port address translation, and might be very useful access control lists, ACLs, extended ACLs and stuff. I think the things I'm saying might be going like a crow from the top of the head of a lot of people. So I'll keep it short. Um, right, just revise this one, and I'll see you in my next video. Thank you so much for subscribing to me and giving me so much love, friendly love, yeah. And please do share my videos, and bye to all over the world. Bye.